Image processing and computer vision fundamentals. Fundamental concepts part 1. Overview. Early days of data of computing. Data was numerical. Later textual data became more common. Today many other forms of multimedia data are there. Each of these types of data are signals, and a signal is a function that conveys some information. Concerned fields of signal processing: digital communication, compression, speech synthesis and recognition, computer graphics, image processing, and computer vision. Fields that are related to images: computer graphics, image processing, and computer vision. In this table, the input and output of the various systems, processing systems related with images are shown here. For example, in image processing system, the input is image and output is also an image. In computer vision system, input is an image and output is description about that particular image. And in computer graphics, we have been given a description of three-dimensional object data and output is two-dimensional image. And there is another field related to AI. Here we have a description of the particular image and we apply some AI related processes, then we again obtain the description in another form of that particular image. Computer graphics. Computer graphics deals with generation of two-dimensional computer images from the descriptions of real-time 3D object or data. Computer graphics deals with designing suitable 2D scene images to simulate our 3D world. Image processing. Image processing is the manipulation of an image for the purpose of either extracting information from the image or producing an alternative representation of the image. Alternatively, we can say that image processing is a subclass of signal processing concerned specifically with pictures or images, and its main task is to improve image quality for human perception and or computer interpretation. Computer vision. Computer vision is related to the construction of the 3D world from the observed 2D images. Computer vision deals with the analysis of image content. Computer graphics pursues the opposite direction in designing suitable 2D scene images to simulate our 3D world. Image processing can be considered as the crucial middle way connecting the vision and graphics fields. Computer vision system has basically three components: image processing, image analysis, and image understanding. The input to a image processing system is an image and output is also a processed image. Image analysis, input is image and output we get some measurements for feature or some important features. Image understanding, input is image and output that we obtain is a high level description of that particular. Various related fields to images. Various related fields includes robotic vision, signal processing, physics, imaging, neurobiology, mathematics, machine learning, and artificial intelligence. What is an image? Image is a representation, likeness, or imitation of an object or thing. A vivid or graphic representation. Why do we need images? Various imaging modalities help us to see invisible objects due to opaqueness, far distance, or small size. Other signals can also be translated into images to facilitate the analysis. Images are important to convey information and support reasoning. That's why it is said the image is worth 1,000 words. These are the example of some digital satellite images. Satellite images, volcano in Alaska. Medical images, MRI of normal brain. Medical images, X-ray knee, medical images, ultrasound, astronomical images. Now, digital image acquisition process. This diagram explains the acquisition of a image and its digitization process. This is scene element of a given object. When this particular object that is to be imaged is illuminated by some imaging device which is operating by some energy source, then the reflected light, or in some cases in X-rays refracted lights, goes onto the film of the imaging system where it is captured during its exposure time. And this captured image may be analog or digital. Nowadays, in most of the digital cameras, the image captured is normally already in digital form. But in old cameras, which uses reels to capture the images, the image captured is your analog or continuous image. To process this image by a computer, at first it has to be digitized. For digitization purposes, we use sampling and quantization. From analog to digital, suppose there is an object, then it is captured by the imaging system, and for digitization it is sampled and quantized, then it can be stored, and further it can be processed on a digital computer, and this processed output can either be displayed on the monitor or it can be recorded somewhere or it can be transmitted online. Digital image representation. This diagram shows the coordinate convention used to represent digital images. This is a grid of size m cross n, which shows that this image has m rows and n columns. The elements stored in each cell is known as picture element or pixels, which is basically the intensity value of that particular pixel. The whole pixel constitutes the image. Image acquisitions and application areas according to sources of energy. In practical, basically there are various imaging devices which operate in different energy bands. In coming slides, I will explain the various imaging devices operating in different energy bands of electromagnetic spectrum, and we will see its possible applications of each imaging device. Examples of fields that use digital image processing. Yes. Categorized by image source. Radiation from the electromagnetic spectrum, acoustic, ultrasonic, electronic or computer generated. Sources of energy. This diagram shows the electromagnetic spectrum. Here energy per photon is shown here. Here the first band, which is in between 10 to the power 4 to 10 to the power 6 is gamma rays, then X-rays, then ultraviolet, visible, infrared, microwaves and radio waves. This is the standard view of electromagnetic spectrum, which shows the frequency, wavelength and energy of each photon in each band. Examples: gamma ray imaging. Here on left side 4 images are shown. First image is an example of nuclear imaging, which is a bone scan of human body obtained using nuclear imaging. Second image on top left is a positron emission tomography (PET) image of human body. Third image, which is bottom left, is an application of gamma ray imaging used for astronomical observations. This image is a Cygnus blue. Another application of gamma ray imaging is in nuclear reaction. Gamma radiation from a reactor wall. This is the example of nuclear reaction. Examples of X-ray imaging. Examples include medical diagnostic. Images shown are chest X-ray, aortic angiogram, CT head. In addition to medical diagnostics, X-ray imaging is also used in industrial imaging. Example is a circuit board for inspection of faulty circuits, and in astronomy. Imaging in ultraviolet band. The application areas include lithography, industrial inspection, fluorescence microscopy, lasers, biological imaging, astronomical observation. Imaging in infrared and visible bands. Example areas include astronomy, light microscopy. Examples of light microscopy includes in pharmaceutical industries, microinspection to material characterization. Remote sensing, weather observation and production. This diagram is a multispectral image hurricane identity from satellites which shows the movement of the hurricane. This particular image can be analyzed by a image processing system and required information can be retrieved. Again, example of remote sensing, nighttime light of the world. Another example is your visual spectrum. Here it has a lot of industry applications. The figure shows here a circuit board, pill container, bottles, bubbles, cereals, and image of replacement lens for human. Visual spectrum application areas are law enforcement. For example, analyzing thumbprint, paper currency, automated license plate. Imaging in microwave band for radar imaging. This left image shows the radar image of mountains in southeast. Imaging radio band used by the MRI machines used in medicine and astronomy. Other imaging modality that uses neither of energy band from EM radiation includes acoustics imaging used in ultrasound imaging and geographical explorations, and another is your computer generated. Again, acoustic ultrasound, computer generated images, fractal generation, 3D computer model, general purpose image processing. Now, image processing. What is it? It is basically manipulation of multidimensional signals. Image fxy, video fxyt, another space is added here. CT MRI 4 dimensional xy. Image processing. Why it is required? We require due to various reasons. The reasons include coding or compression, enhancement, restoration, reconstruction, analysis, detection, recognition, understanding. Computer vision framework. Input image processing, feature extraction, segmentation, feature extraction, symbolic representation, classification and description, interpretation and description. Left side constitutes the image analysis system, and this is lower shown by this particular block is image understanding system. And this is your conclusion, data analysis and conclusion from digital image processing and computer vision. Basically, there are three levels of processes: low level process, mid level process, and high level process. In low level process, input is image and output is also an image. Examples of low level process includes noise removal, image sharpening. Mid level process, input is image and output is attributes extracted from the particular image. Examples include object recognition and segmentation. In high level process, input is attributes that have been extracted from the image from the previous state, and output is the understanding of the image content. Examples include scene understanding and autonomous navigation. Digital image processing major steps. This diagram shows the major steps of digital image processing. At first, we start from problem domain, then image acquisition, then image enhancement, image restoration, morphological processing, segmentation, object recognition, representation and description. Image compression and color image processing, they are also considered as basic tasks related with images. In this slide, the image acquisition has been shown here with the help of this diagram. Image enhancement, left side poor quality illumination image and right side is the enhanced image. Image restoration, restoration of the degraded work image. Then morphological operations, examples show the various operations related with it. For example, opening, closing, dilation and erosion. Then segmentation, object recognition, representation and description. Example of image compression for compressing the size of the image. Color image processing. Image processing major steps, review steps with some other examples. In image acquisition, an image is captured by a sensor and it is digitized before being processed by a digital computer. If the output of the camera or sensor is not already in digital form, then an analog to digital converter digitizes it. With the diagram of a typical camera that is used to capture. Frame grabber card. Frame grabber only needs circuits to digitize the electrical signals from the imaging sensor to store the image in the memory of the image enhancement. Basic work is to bring out detail that is obscured or simply to highlight certain features of interest in an image. Examples of image enhancement. Enhancement of MRI images by using power law transformations are shown here. Image restoration, responsible for improving the appearance of an image, tend to be based on mathematical or probabilistic models of image degradation. This is left hand side distorted image, right hand side is restored image. Types of distortions in images. Distortion due to camera misfocus. Distortion due to motion. Distortion due to random noise. This slide shows the various types of noise in an image. Examples include Gaussian noise, Poisson noise, Sartre beacon noise, speckle noise, motion blur, uniform noise, exponential noise, and other types of color image processing, gaining in importance because of the significant increase in the use of digital images. Image compression, used for reduction of storage requirement or for saving network bandwidth during transmission. Example, JPEG standard. Image compression, signal processing based approach. Compression stage can be considered as a encoding stage performed by encoder, and decompression stage, decoding phase performed by morphological image processing. They are basically tools for extracting image components which are useful in representation and description. Image segmentation. Basically, computer tries to separate objects from the image background. It is one of the most difficult tasks in digital image processing. A rapid segmentation procedure takes the process a long way toward successful solution of an image problem. Output of the segmentation stage is a raw pixel data constituting either a boundary of a region or all the points in the region itself. Example of image segmentation. Applications: medical imaging, motion tracking, detection or identification of objects in an image, automatic car assembly in vision. Representation and description. Representation: make a decision whether the data should be represented as a boundary or as a complete region. Recognition and interpretation. Recognition: it is the process that assigns a label to an object based on the information provided by its descriptors. Interpretation means assigning meaning to an ensemble of recognized objects. Knowledge base. A problem domain detailing regions of an image where the information of the interest is known to be located. Help to limit the search. Applications of digital image processing. Gray-level image processing, medical imaging, radar imaging, biometrics, remote sensing, copyright protection, digital watermarking, digital holography, image compression, and many more. For example, object recognition, 3D vision, robotics, industrial inspection, etc. Some application areas of image processing and vision: image imprinting, medical imaging, image registration, optical coherence tomography, remote sensing and agriculture, astronomy, digital watermarking, microscopic image processing of biological samples, digital holography, scientific device. Application areas of computer vision: controlling processes, detecting events, organizing information, modeling objects or environments, interaction, 3D. And it may be noted that not all the processes are needed in an image processing system. This is shown by a postal code problem. All image processing tasks are not necessarily being used in every application. Examples of image imprinting. Left hand side image shows a very old damaged portrait that has been recovered by using image imprinting or image restoration technique. Another example of image imprinting includes the removal of text from the images or video, or removal of logo from a video. Or in medical applications, speckle reduction from ultrasound images. There is also a restoration problem. Speckles noise, that is multiplicative noise, they are also present in synthetic aperture radar imaging, and it can also be reduced by using appropriate create imagery restoration. Restoration and microscopy. Restoration and enhancement of microscope. Medical image registration. Final configuration for MRPET registration. Applications of registration. Register to memorize the brain to visualize anatomy. Create a 3D model for surgical planning and visualization. Segmentation. Applications in medical imaging. Semi-automated detection of Alzheimer's disease using segmentation. Active contour model of snakes proposed by Hospital can be used to segment a portion of a framework for snake. Alzheimer's disease description. Segmented hippocampus shown by green. Segmented corpus callosum shown by area. Another application, digital watermark. Left hand side the original image, and this is the logo UPS. This image UPS can be embedded into this original image, which is an example of digital watermarking. Digital watermark may be visible or invisible depending upon the type of applications. Basically, it is used for copyright protection purposes. Applications of computer vision in space. Remote sensing and vision in agriculture. Remote sensing and vision in agriculture, another example. Arable precision farming cycle. Another example of agriculture.